Hey everyone, welcome to Gophercises exercise 17, getting very close to having 20 of them and calling this a complete project. I say that in quotes because I'll probably add more exercises. So in this exercise, what we're going to be doing is building a secrets CLI and API. And this is going to be heavily inspired by Vault, which is a HashiCorp project. The short version of what Vault does is basically just a simple way to store secrets that is a little bit easier than, trying to keep them all in files on your computer, uploading them to wherever you need them. It gives you ways to sort of give people access to certain secrets and then revoke it later. So there's a couple of different things that sort of go on there behind the scenes with it. We're not going to build anything nearly as complex, but I thought this would be a cool way to sort of look at some of the crypto packages inside of the Go standard library while, just getting some hands-on experience, seeing how they work. And I will give you the warning here jumping into this. When it comes to cryptography and that sort of stuff, you really shouldn't write cryptographic type code or you shouldn't write anything like this without really understanding what it does and how the cryptography stuff works, what's secure, what isn't secure, and really understanding all of those details, because there's a good chance that you might leave yourself vulnerable to some sort of timing attack or something else. So knowing that, we're still going to build something. I think it's still useful to get a feel for how these packages work, to look at the examples in the standard library and just to mess around with them and just build something cool. But I also really like this project this exercise, because it's going to give us a chance to look at some different interfaces and how we can do something sort of like interface chaining in Go. And I think this is a really cool concept in Go that a lot of people don't quite, jump into right away, or they don't see very often. So seeing how this interface chaining can really essentially allow us to make it so it's much, much easier to read and write our files as if we didn't even know they were being encrypted is just a really cool thing that we can do here. So we're going to go ahead and be building something like Vault. And I don't have the best README right now. I plan on updating it once this video is done and once I really have the code done. So what I want long-term, though, is just some sort of command line application that's going to look sort of like this. I want to be able to type secret set, some key, so Twitter API key might be the name of what the key is, and then some value and have it set somewhere. So probably in my home directory, I'll have some sort of file that it encrypts and it keeps that key there. And then later I want to be able to type secret get Twitter API key and it to output something like some value or whatever I stored there. Now, this might not be the final version. I might decide that we need to pass in our encryption key as a flag here. So maybe that's what we'll do. Or maybe we'll say the encryption flag, let me show you what I mean. So we might say, you have to pass in a flag here like key equals ABC123. Or it might be something where you're expected to instead have this key. Let me just go ahead and create a new line. The other option is maybe it makes sense to do something like secret key equals ABC123 and then run our program. So in this case, this is an environment variable that's being set for this run of this program. You could also just set it on your system. So like if you pushed your code to a production environment, you could have it so this was sort of an environment key set or environment variable set. And then every time you ran this, it would just automatically use it. So I'm not sure which of those we're going to do. I'm guessing we're going to need one of them, but I don't know which I'm going to choose to do. And then if we come down here, the other thing that I want this package to be able to do is to also be usable inside of Go code. So we look here, and this is probably not going to be the final version. I'm not expecting it to be, but the rough idea is that I want to be able to get some encryption key somehow. I want to be able to use the secret package, which is something we're going to create, to, set up a client or do something. This is probably not the way it's going to end up looking in code, but that's okay. But then once we have a client with an encryption key, we want to be able to get something like a Twitter API key, and we want to be able to set things like set an API key. So again, it's going to have the same functionality we have up here, but it's going to be inside of some Go code. So knowing that we're going to be writing it in Go code like this, we can actually use this to build the CLI part up top. So we're going to start with this second part here, and then we'll eventually get to this top part, which is just going to be using that code. And I think that's enough for a description. That should give you a rough idea of what we're trying to do. Now, if you want to try to do this on your own, go for it. Just remember what I said about encryption and how, if you don't know what you're doing, there's a good chance that you shouldn't release this to the public or advertise it. It's completely fine for your own API keys because people will store their own API keys on their own server in a plain text file. And that's kind of what we're trying to get away from is, something a little bit better than slapping them in a plain text file, or maybe a JSON file that we read all our keys from. I don't know if you've ever been to a project where, they just have an env file. I don't have one here handy, but they'll have some big env file where it'll be things like Twitter API key equals ABC123, Dropbox API key equals XYZ 999. They'll have a bunch of these in here, and all this will get set into the environment variables when they run their program, and then they'll use those different environment variables, in their application. And that allows them to keep different keys for each developer. They don't have to give their production keys out to every developer. They can have a separate file they keep on their production server that not every dev has access to. So there's a lot of benefits to this approach. We're just trying to do something similar that adds a little bit of encryption. And as we build this, you'll start to see why I think this is also a cool exercise, because it takes these things we're learning and allows us to apply them to things like readers and writers that are interfaces that we can start to chain with and build some cool stuff. Okay, so with that, we're going to jump into actually starting to code this. So jump to the next video for that. We're going to start this exercise out by writing the encryption code, or the code that we're going to use to encrypt our files. Now, I'm going to warn you that, again, this is the type of thing that if you're writing it and you don't have somebody who is an expert in this type of thing reviewing the code, you really shouldn't be pushing out as a public package to a bunch of people. And in this case, I think we're going to be okay with it because we're mostly going to be using examples from the standard library, and they're going to be fairly contrived, simple examples. But, again, that's just something to keep in mind. And I'm not going to go into too much detail as to what things I'm using and why they're there. The code that I'll copy paste from the standard docs will have some, comments, and they'll explain a little bit. And you can dive into it if it's something you're interested in, and I think you should. But I don't want to try to teach that here because it's a very sensitive subject. And if I misrepresent anything or I misstate anything, it could lead to potential issues. So I would rather you go learn that from somebody who's an expert on the matter, and I don't consider myself an expert on cryptography at all. So what we're going to be doing is, I got a couple examples here that I want to kind of show you as we go through here. So I'm going to start with the Cipher package. And inside of here, one of the things that's kind of cool about the standard docs having these examples like they do is that when you want to learn how to use, say, this Cipher package to encrypt and decrypt some data, you can come down through here and look at the CFB encryptor and CFB decryptor. If you click into it, you'll see that there's examples. Now, these aren't really, really tiny examples that just show you, one argument to pass in and one, value to pass in here. Instead, these actually allow you to, see a full working example pretty much where they have a key, they have some plain text, they create a cipher, they go ahead and then they create the, the CFB encryptor. They call that all the way down here. So you'll notice that there's a lot of other things going on, and this is actually a pretty complete example to give you an idea of how this is supposed to work. So that's something I really like about these docs is that, even if you don't fully understand this perfectly, you can still at least toy around with it for something like what we're doing, a little pet project, and start to learn about it by looking at the code that they provide for you. So we're going to go ahead and copy all this code, and I'm going to come back here and we're going to create, let's call it, I'm going to call the package encrypt, I guess. And then inside of that, we're going to create a file named cipher.go. It's going to be package encrypt. And we're going to start with two functions. We'll eventually move the design, or change the design a little bit. But the two functions are going to be encrypt, which for now is not going to take in any arguments or return any. And then we're going to have a function decrypt, which, again, for now is not going to do anything. But long term, what I'd like these two to do is give us a way to, excuse me. I'd like these two to give us a way to pass in enough data to encrypt something, and then decrypt to do the same thing to allow us to pass in that, whatever we get back from encrypt plus whatever other data we need to give it in order to decrypt something. So I'm going to go ahead and just paste the code that we got in here because this is supposed to be some encryption code. It's coming from the CFB encryptor here. And then the decryptor is right above it, so we can get that code too. And I'm going to copy it all. and I'm going to paste it into Decrypt. So I'm going to save this. It's going to import a bunch of different packages up here. And we're going to walk through just briefly looking at, what's going on and figuring out what pieces of information we're going to need for our encrypt function. So the first thing is that this talks about, obviously you shouldn't use this example key. And then the other thing, sorry, it's been a long day. If we want to convert a passphrase to a key, or, it's talking about converting a passphrase and stuff like that, do not use this code to store user passwords or something like that. Whenever you're dealing with user passwords, you should be hashing them, not encrypting them. If you can ever take a password and turn it back into its plain text value, especially user stored passwords, you're doing it wrong and you shouldn't be doing that. You should be using something like bcrypt or scrypt, a hashing function that is going to allow you to store their password secure, or store a hash of their password securely that you can then verify against without actually having a version of the password that is, able to be reversed back into the plain text. So with that little caveat out of the way, looking at the code here, the first thing it does is it creates a key. And obviously we don't want our encrypt function having a hard-coded key in there. That wouldn't make any sense. So if we look at this key is a byte slice. And that means that we're going to need some sort of key. It's going to be a byte slice. And it's going to have to get passed into our encrypt. But then if we go a little bit farther down here, if we go to aes.newCipher, this is where we're passing in the key here. I'm actually going to go to the definition, which will bring me to the code definition. I could have just gone to the standard docs that are here, and I could have read it right here. But I just wanted to show you that you can also jump to the code, at least in VS Code and other, if you're an Atom or something else, a lot of those have tools to do stuff like this. So we can jump to this code, and you'll see here if we read this that it says that it's going to return a new cipher.block. The key argument should be in the AES key, either 16, 24, or 32 bytes. Now, I'm pointing this out because it means that our key has to be a specific size. So if we go back to our code, taking in an arbitrary byte slice might not be the right idea. Or maybe it does make sense to let the key be sort of arbitrary, but that means that we need to find some way to turn it into that format we want. So what I'm actually going to suggest, let me just show you what I mean here. Let's go to the Go playground. I had an example here. There we go. This is what I wanted. So let me take all this code. Let me just create a new window that I can temporarily store this in. So that's all that code that was there. I'm going to take this code. I'm going to go ahead and just get rid of these comments. And then I'm going to go ahead and grab this key byte slice that I created to sort of demonstrate this. Now I'm going to format this all. So this key byte slice is a very, very long string. You can see that, it's just way too big. It's going to be more than 32 bytes. And if we call aes.cipher with this key and then run it, it is going to give us this error, invalid key size, 176. So what do we do if somebody wants to use a key that's something like this? Well, one of the things we can do is use MD5. So we can, here, let me go ahead and grab the code here. We can use MD5, which is basically like MD5.new will generate a hasher. We can just look this up in the standard docs, because this is probably really small looking at that. So when you call new, you'll get a hash.hash. And then with a hash.hash, if we go look at that, we will be able to sum. Sorry. We have a writer and we have a way to sum. So with this, we can write some data to the hasher, and then we can sum it, and it'll give us a hash result. And what's nice about this is that it means that we can take any arbitrary string, no matter how long it is, and pump it into this and get a result out of it. But what's really, really nice about MD5 is that we're going to get a constant sized return value. So if we run this, if we run this one here, or if we run any other ones, you'll start to notice that this is printing out the hex version of it. And, regardless of what we pass in, I passed in these two strings. Now, if I go to the share link and I change this to make a little bit more in the string and I run it, you'll see here that this is going to be the same length. So we've got this, it's coming to, this, well, I'm going to guess that it's, let's do len. I just want to show you. So this one is 32 bytes, or sorry, 32 hex characters. It's actually 16 bytes if I recall correctly. So if we keep changing these and running it, every single time it's going to be exactly the same size. So this is something that's really nice about MD5 is that it's always going to be producing the same sized output, regardless of what we put right into it. So this essentially means that whenever we go to create our sorry, let me go back here to our code. This one here. What this essentially means is that when we want to create this new cipher, if we have a string that's way too big, or maybe just to make our code easier, one of the things we can do is to always use an MD5, hash whatever key we're given, and then use that hash value as our cipher key. So what we can basically do is something like, so cipher key is going to be hasher.sum nil. And then down here, I need to move this key up. Put the key there. And then I'm going to get rid of this line. And let me just format this and run it. Cipher key declared not used. I need to pass that in here. All right, so you see that we don't have any errors. That's why it's, the program's exiting because there's no errors. And if we print out the length of the cipher key, you'll see that we're getting 16. So it's 16 bytes. And as a result, we can just go ahead and just use this cipher key every single time, as our cipher key for AES. So that's what we're going to do. We're going to, just whatever they pass in, we're going to MD5 hash it, and then we're going to use that as a cipher key. And that means that we can take an arbitrary length string as our key. So I'm going to go ahead and copy all this code. Come back here, and I'm going to say key is going to be a string. And I'm going to paste this up here. So hasher is going to be md5.new. I'm going to get rid of this line here. And then if you remember that other example we were looking at, this one, you'll see that they use io.writeString, and that allows them to write. So H is a writer. It implements that writer interface. And that's because it's a hash. So if we go here, the hash has an io.writer interface inside of it. So it's implementing that io.writer interface. So that means we can use anything that would normally write to that. And we could even do something like fprint, and we could write hasher is where we're going to write to, and the value we're going to write is the key. So they're using io.writeString. I'm not really sure if there's a major difference between the two. If you want to use io.writeString, you can, but I'm going to go ahead and use this for now. I think as long as you're consistent, it should be fine. And then we're going to get rid of that line, and then we're going to sum the hasher and get the cipher key. We're not going to print out the length like we're doing here. And then once we get that, we're going to get a cipher. What do we call that down here? Oh, it's a block. It's not a cipher. So new cipher is going to return a cipher.block and an error. Okay, so we'll get the block and the error. And if the error is not equal to nil, we're going to need to return that error. So I'm going to return just an error for the time being, even though I know I'm going to end up adding more return types. Okay, so that should be replacing a good chunk of the code we started out with. We don't need this anymore. The plain text, we're still going to need to figure out something with that. And then we have this block stuff. We've replaced all that with our own custom code. So this is all the code to allow us just to pass in arbitrary length key strings. And part of the reason I'm doing this, or the main reason why I'm doing this, is that by allowing users to pass in just a key string, it just makes it easier for them to use this. They don't have to think about what's the length of this. They don't have to think about how do I convert it. It's just a nice little helper function, helper functionality that makes it simpler for people using this, so they don't have to think about these details quite as much. Now, there are probably some downsides to this. Maybe it limits, we're using AES 128 instead of 192 or 256. So there might be cases where this doesn't make sense, but I think for now, this is a completely logical choice to make. All right, so the next thing we have plain text, and this is what we want to encrypt. This is the value that we're encrypting. And I think that we should have that passed in. So along with the key, we're going to have something like plain text. We'll call it a string for the time being because it shouldn't be too hard to convert that to a byte slice if we need to. So we shouldn't need that. And then if we come down here, you'll see eventually when we pass in plain text, it's going to complain because it's not a byte slice, but we can deal with that in a moment. Okay, so this next part, the IV, that stands for Initialization Vector. I'm not going to go into the details of what this is. The short version is that you slap some block size data at the front of your ciphertext, or yeah, basically at the front of your ciphertext, I think is where it is. So you put it there, and it doesn't have to be anything like special. It doesn't have to be secure. It just has to be unique, and you're doing it so that every time you, it's something to do with whenever you're encrypting, you want to make sure that it's not easy for people to sort of guess what your key is by looking at encrypted values. You know, this being random sort of makes it impossible for them to guess that, I suppose. Or I think that was the gist of it. It's been a long time. So we're going to go ahead and just keep this code, but we're not going to make any changes to it. So we're going to say ciphertext is whatever they're doing here. So they're basically making a byte slice that is the block size plus whatever the length of our plain text string is. And then they're going to come down here and they're going to say ciphertext, the slice that's the front of it. So whatever the first block size that they just added to this new slice, they're going to call that IV. And then they're going to use io.readFull and rand.reader. And it is important to mention that this is the crypto/rand. It's not the math/rand package. So that's, definitely make sure you're using the crypto rand if you're doing something like this. And this is going to essentially just read random bytes into this slice here. So something block size. And if it has an error, we don't want to panic. We want to return the error. Okay, so finally, we come down here where it creates a CFP encryptor. And then it will use that stream that's created from the encryptor, and it will use the XOR key stream, pass in ciphertext. So it's going to pass in the ciphertext everything from after the initialization vector to the end of the slice, and that's where we're going to be storing our results. So like that's the destination. So if we look at the the definition here of the XOR key stream function, the destination is the first argument. And then the second part is supposed to be a byte slice that it's our source. So however we're writing to it. And we're just going to do byte like this to make plain text a byte slice. And then finally they print out, okay, not sure what I did. Okay, finally they print out the ciphertext here, and they use %x, which I believe prints out the hex encoded version. We're not going to be doing that. So we need to return this. The question is, do we just want to return a byte slice, or do we need to return a string? And long term, we're going to be doing byte slices, but short term, I think a string is fine. I think a string is just a little bit easier for people to be used to. So let's just go ahead and change this to be sprintf. We'll get rid of the new line. We just want %x ciphertext, and we'll do nil here for the error. So we'll return these two. And this also mentions that ciphertext must be authenticated. Basically what they're saying there is that when you have a ciphertext, you should hash the results. I think what they're saying at least is that you should hash the results so that later you can tell if somebody altered the encrypted data. So when you go to decrypt it, you'll get some invalid result. So the hash will help you verify if that's the case or not. We're going to go ahead and skip that for the time being, only because one, we're a little bit limited on time. And two, I don't think it's super important for what we're doing. We're dealing with files on our local file system. It's not something where people can easily come in and start corrupting our data. Realistically, what we're mostly worried about is somebody just happens to get a hold of this empty, this file that has all of our API keys. And if we at least have it hashed, it's going to be a little bit harder for them to do something with it. So I'm going to go ahead up here and just change this to have the return types of string error. And I think that's roughly all of it. So you can see here that it's not too crazy long, not too complicated, but it should allow us to encrypt. And now we're going to come down here and do the same thing. And you'll notice that we need to pass in a key here again. So we need to do that same, all this stuff here. So what might make sense is to get this cipher stuff and to copy that off to a function that's not exported. So we'll say func, new cipher, key string, and it's going to return a cipher.block or an error. I think it can return either of those. And we'll say, we'll run through all of this. If the error is not equal to nil, return nil, error. Otherwise, return, well, I guess at this point we can just return whatever this creates. All right, so we got new cipher from a key. So now I can come up here, and with all of this, I can say block is going to be new cipher. I should probably call it new cipher block. Or I could just call it new block. I'm not really sure. I'll call it new cipher block. And this needs an error. Say if error is not equal to nil, return empty string error. And then I'll copy this stuff here, come down here to decrypt, paste it in, and we're going to say key, which is a string, is going to be one of the arguments here. And then this is going to return, I think we're going to either return the decrypted value, which will be a string, or an error. And then I also know that with the values passed in addition to the key, I also need them to pass in the the encrypted value. So we'll call it encrypted value. That's not the best name for it. Maybe ciphertext. Cipherhex is the best way to put it. We'll see if that works. Okay. So we're going to come down through here and okay, so you see here they have ciphertext is going to be, they're going to decode the string. That's actually something we want to do. So we're going to say ciphertext is underscore error equals hex.decode string, and the string is going to be cipherhex. Then we'll say if error is not equal to nil, return empty string error. And that's all we're doing here. So we know up here we turn this into a hex value. So down here, whenever we come to decrypt it, we need to turn it from that hex value back into a byte slice. And that's what we're doing here with hex.decode string. So we're going to delete all of this now. All of that is handled by these first two parts here. And all we need to do at this point is make sure that we can decrypt this all. So this first part, the initialization vector, IV, needs to be unique, but not secure. Therefore, it's common to include at the beginning of the ciphertext. So that is what we're doing. If you look up here, we're including the initialization vector at the front of this ciphertext because it's the first block size chunk or slice, or part of the ciphertext slice. So that's what we're doing down here, is we're going to go ahead and pull it out. And before we pull it out, we're going to actually check and say if the length of the ciphertext is less than the block size, well, then we know that there's no way there's an initialization vector in there because, it's not big enough. So we know that, this is not valid data in some way, and we have some sort of error. And rather than returning this, I think we're going to return errors.new, encrypt. We'll do something like cipher too short. I think that's fine for the time being. If somebody really wants to know what's going on, they can come look at this code. Okay, so then we get the initialization vector out of the ciphertext. From the ciphertext, we reassign it to being everything but the initialization vector. That's what we really want it to be anyway. And then we create this stream, and this is going to be a new CFB decryptor. But we initialize it pretty much the same way. Up here we have a block and initialization vector. Down here we have a block and an initialization vector. So both ways. And this apparently, I think I mentioned earlier that the initialization vector is used to, it's added to the front, but it's also used to make sure that it's not really easy to figure out what encryption key we're using. And you'll see down here that same thing's happening. They're using it here to also make it, they're using that initialization vector. Then when we decrypt, so that it can actually figure out what the real key should be based on the key we provided in the initialization vector. The best way to probably describe this, and I don't actually know if this is what it's doing behind the scenes, but I assume what this is probably doing is something like salting a password. For those of you familiar with it, whenever you go to hash user passwords, you'll often take the password they provide, add some salt to it, so some string that you store maybe in the database or something like that, and then you hash the entire thing. So now if somebody gets access to the password, they can't try to figure out what the password is without also knowing what that salt was. And, it just makes it much, much harder to figure out what the original password was because they have to, figure this out, and then if they need to do a bunch of rainbow tables, they have to generate them all for that specific salt. Whereas in this case, what I'm assuming it's doing is it's not quite the same, but same idea where you take the key that we have, you could probably attach the initialization vector to it, and now we're using that as our real key that we cipher or we encrypt with. So, when they go to encrypt, every single time we encrypt, we have a different initialization vector. So it's almost like we use a different key, but this end part of it is something that, is easily accessible because it's just the start of our ciphertext. So they could always figure that out, but it's still much, much harder for them to figure out what this first part is because, we're not encrypting data with just that, we're encrypting data with two parts. And I know that might not make the most sense in the world, but the best way to put it's like if you're encrypting with the key A, just the letter A, that's going to be, you can try to figure out that that's the key they're using. But then if you encrypt with the string AB, that's going to be, it's going to give you much different results. And if you do AC, that's going to be different results. But those results aren't going to sort of imply what A is. It's going to be hard to figure out what that is. So I feel like I've gotten way off track. Let me come down here and just get rid of this comment. And so we create the stream, and then it can work in place if the two arguments are the same. So basically what this is saying is that we can pass in ciphertext as both values here. So what it essentially means is that we can pass in the ciphertext as the source and also as the destination. And what ends up happening is it just replaces what was in ciphertext with the decrypted string or the decrypted bytes. And then finally we want to return this string. So we're going to do return fump.sprintf %s ciphertext comma nil. And really all we're doing is just turning this into a string. So what we could probably just do at this point is just do something like this. Okay, so that should be everything. I am going to comment two quick things here. The first is Decrypt will take in a key and a ciphertext. Of the ciphertext and decrypt it. This code is based on the standard library examples at and I'm going to copy all this, say encrypt. We'll take in a key and plain text and return an encrypted version of the plain text. Let's say return a hex representation of the encrypted value. I don't know. And then this is based off of the CFB decryptor. Or encryptor, and this right here is decryptor. Okay, so I feel like I kind of went off on a tangent a little bit on this. Originally, when I created this exercise, I planned on not even explaining this code. I planned on just writing this on my own, giving it to you, and being like, just use this code. But I kind of wanted to dive into it because when we get to the interfaces and the writers and that sort of stuff, there's gonna be some benefits from seeing it. So I wanted to jump into it, but I'm sorry if it bored you or if it was really confusing. The rest of the exercise is going to be a lot more fun. We're basically just going to be using this type of stuff to write the rest of our code. But I think that's enough for now. Let's go ahead and commit this. I'm going to commit it to a branch, but you can jump to the next video if you're ready to move to the next part. So the last video is meant to be optional. So we're going to assume that either you followed along with it or you didn't. It really doesn't make a difference. But what we're going to be doing from this point on is we're going to be using this encrypt package to build some sort of, secret vault type package, something similar to the vault from HashiCorp, but much simpler, much more narrow use case. Basically, we're just going to find a way to store different passwords and have them encrypted, and then when we request them, it'll decrypt them. So what I'd like to have or maybe not long term, what I'd like to have in this video is to just create something like, let me set the language to Go, something where we can create a secret vault, and maybe we pass it in my key, or this is our encryption key. And then we can just do something v.set, Twitter, and then some value. And then later we would do v.get, Twitter, and we would get some value back. So this is all going to be in memory. So what we're probably going to do is just go ahead and, whatever this is, we're just going to encrypt it and then store it in memory. And then when we call get, we'll decrypt it and return it. So this isn't going to be crazy useful, but I think it's a good starting point just to sort of get a feel for what this set and get methods are going to look like. And then what we're going to do in the next video is we're going to change this so that whenever we create a vault, we're also going to provide it a path to a file. And so it's going to be something like path to file. And then when we call set and get, what it's actually going to do is read a file that's encrypted, decrypt the entire file, and then once it's decrypted the entire file, it's going to set a value and then rewrite the encrypted version of the file. And then get is going to be similar. It's just going to read the entire encrypted file and just print out the value. So, these two are going to be, it's going to be a little bit different implementation-wise in the second version where we're using a file. But I want to do the first version just so we can see how we use our encrypt functions, because this second version here with the file, we're going to be taking them and tweaking them a little bit, but I want you to get familiar with using them first. All right, so knowing that this is roughly what we want our code to look like, let's make dir, well, I guess we're already in secret, so let's code vault.go. And I'm going to call this package secret. And we're going to go ahead and just say something like type vault struct. And it's going to have something like your key, encoding key. And I'm not going to export this. I'm just going to go ahead and keep it not exported. That way later on, if we were to pass this to other code, it wouldn't have to know what our encoding key is in order to have access to this type of information. And that leaves us with this weird predicament of I wanted the function to be called vault. So we wanted func vault with some sort of key. So this is going to be encoding key to return this vault. So maybe this should be called new or new vault. I'm not really sure. Let's just call it memory, because this is going to be the in-memory vault. And even that's going to be a little bit fuzzy. Well, that'll be fine, I think. It's going to return a vault, and I'll show you how we'll fix that later. Okay, so we do this in-memory one. It's going to return vault. Encoding key is going to be encoding key. All right, so this is going to return us this... oh, it's complaining because I have a main package here. I'm just going to delete this for the time being. Okay, so this vault is going to be this vault type, and I'm not going to comment any of this for the time being. And what we're going to do is we're going to add some methods onto vault. And it's going to be get. It's going to be a key, string, and you need to keep the difference between the encoding key and the keys for our key value pairs are going to be a little bit different. And this is going to return a string or an error. And I don't really know how this is going to get it, so we'll just go ahead and just say key values. Give me a map, string, and string. Yeah, that's right. So up here where we created our vault, let's go ahead and just make sure we get this set up ahead of time. So let's say key values. It's going to be make, map, string, string. Okay, so what we're going to do now is we're just going to assume no encoding and just get this working without that. And we're going to go ahead and do v.keyValues, key. So if ret, comma, okay, it's going to be this. If okay, return ret. And this is going to be ret, comma, nil. Otherwise, return empty string, comma, errors.new, secret, no value for that key. And now we need a set method. So func v vault set key value string, and this is just going to return an error. And again, we're not using any encryption here. We're just getting this working, and then we're going to add some encryption. So we're going to do v.keyValues key equals value. And then we're going to return nil. So you can see that the set is very, very simple, but that's okay. So let's make dir command, and then let's code command main.go. We'll just call it demo.go. Package main, func main, and we'll do v is going to be secret.memory, and my key, say my fake key, set Twitter, let's say demo key. Some crazy value. I don't really need the dash, so some crazy value. And then we're going to say error is going to be equal to that. If error is not equal to nil, panic with the error. And then we're going to say plain comma error is going to be v.get demo key. So we're going to print line. Well, first we'll just say if error is not equal to nil, panic it. All right. I think that's everything. It's got it all working. Let's go ahead and go run command/demo. All right, so some crazy value. So this code appears to be working for the most part. Let's go ahead and add encryption now. So we're going to use that encrypt package we created to do this. And we'll do it with the set first because I think that's the easiest one. What we want to do is say encrypted value comma error is going to be encrypt.encrypt. And we're going to pass in v.encoding key, and we're going to pass in value. And I'm going to make sure, yes, it imported the right package. And it's returning string error like we're expecting. Okay, I think all that's good. So what we're going to do now is we're going to say if error is not equal to nil, return error. Otherwise, we're going to set this to encrypted value and return nil. All right, so if we run this now, it shouldn't work. Yeah, we're getting some hex value here, which is obviously not right. So forget we want to get this value, and we're going to actually change this a little bit. I'm going to copy this first part, and I'm going to make it up top. And I'm going to say, if not okay, we're going to come in here. And the reason I'm doing this is you'll see me and a bunch of other people tend to do this. If you have all your like exit clauses inside of an if statement, so you go if here, if there's an error or something like that, we go in here. Then when you're done with it, you can return, so that if you basically follow this code on the left-hand side, that's mostly my happy path. That's mostly the code when things are going well. So it's just a little bit easier to follow. And it also just helps having code that's like if X, if B, and you just get really indented where it can be much, much harder to read the code, especially if you're using more than 2 spaces for tabs. So I'm going to say if not okay, we have this error here. Otherwise, we're going to do, and this isn't even ret, this is encrypted value. Then we're going to say ret comma error is going to be encrypt.decrypt. Pass in v.encoding key, and ciphertext is going to be this is really a hex, so that's fine, I'll call it hex. And then if error is not equal to nil, and then finally we'll return ret comma nil. And at some point it might not make sense to take these errors from encrypt and return them directly. Maybe it would make more sense to make a generic error like failed to decode that value or something, or our internal memory got corrupt. I don't know, but for now I'm just going to go ahead and return them. And I'm going to go ahead and try this again, and it's working again. So that's the in-memory representation of all this. And that's really all we wanted to get done for this first, this first implementation of it. And I think that's fine. It's not crazy useful because, if we have access to the plain text values in our code, not really a whole lot of use to encode them. But I wanted you to see how this encrypt works and get a rough idea of what we're going to be doing. So now what we're going to do is we're going to change this code. We're going to write a new implementation that, instead of being on memory, is going to read from file. And it's going to slightly alter, I think we're going to alter the encrypt code a little bit to get us readers and writers. So we'll do that in the next video. For now, this should be good, and we're ready to move on. Okay, so let's go ahead and create a similar version to this that reads and writes to a file. And in doing this, we're actually going to... So I think what we're going to do is we're going to set up code that will just encode, like we're going to create a JSON output for the file, and then we're just going to encode that entire thing using our encrypt package, and we're just going to slap that whole thing into our file. And then we're going to decrypt that whole thing into a JSON blob, and then we're going to read it. And that's not going to be the long-term solution, but I think that's the one that uses the code we have. And it's a good starting point just to sort of get an idea for how our final version is going to look. And then we're going to look at how readers and writers can really simplify that. Okay, so we're going to call this func file, and it's going to return, it's going to return a vault still, but it's going to take an encoding key, and it's going to take a file path. So we'll call it a file. And we're going to say this could also return an error. I should have returned a pointer to a vault because all our methods are pointers probably, but it's fine. Before it was fine at least. Now we got vault error. And we're going to say... well, we don't actually open the file right now, so we don't need the error right now, I don't think. Alright, so this is going to need... We'll call it file path. And this is supposed to be file path as well. So here we're doing file path. String is going to be file path. I think that's fine. Oh, it's supposed to be and vault now. And then down here we've got our vault. Everything there looks fine. What's going to change is get and set. So what we really want to do is we want to, for get, we're going to open up the file. We're going to load it into these key values. And then once we've loaded in the key values, we're going to just return the value from it. So I'm going to call this func sync key values, or yeah, we'll call it load key values. It's going to return maybe an error. And what this is going to do is it's going to say os.open file path. And I think we need to change this because I think os open golang. I know this is read only, but I don't think it creates a file if it's not there. I mean, I guess that's fine if we don't care that much about it. But I think it's just going to be easier if we just have it create the file if it's just not there. Well, maybe not. What is there a specific error? That's the question. Let's go look at this. I feel like I've done this in another exercise and I'm just forgetting. It'll be of type path error. Well, that's not very... Whatever. What I'm going to do is, if there's an error opening the file, I'm just going to assume that it was just an empty, or it was a file that didn't exist. So we're just going to say, if error is not equal to nil, this needs to be a method. v.keyValues is going to be make map string. So we're just going to initialize it as a I want this to be equals. Basically, we're going to initialize it as an empty map. And we don't really need this now since we're not doing that until this point. And this is going to be v.filepath. So what we're doing is we're saying whenever we call load key values, we're going to open up v.filepath. This is going to be file, error. And if there's an error, we're going to assume that we just need to set the key values and return. And this might not even need to return an error then. Yeah, I guess it could. So, okay. So this is going to return nil. And I'm returning nil because I think that this is one of those use cases that an error likely means the file is not present. And to me, I don't feel like digging into how to separate those two errors. So if you do decide you care later, you can look into them. But I think for now, I'm just going to assume that that means the file doesn't exist. Okay, so now if the file does exist, we want to load it. So I'm going to do decoder is going to be json.new decoder, pass in the file. And then I'm going to say error is going to be json.decode, or sorry, not JSON, decoder.decode. And we're going to pass in and v.key values. If error is not equal to nil, return error, return nil. So basically what I'm saying is I'm going to, if the file exists, we're going to go ahead and we're going to decode whatever's in it into our key values and return an error if there was one. Now the reason up here I'm not doing create the file if it doesn't exist is pretty simply that I don't want to create an empty file and then try to decode it as JSON, because then it's going to complain. It's going to be like, well, that's not valid JSON, it's an empty file. And I don't want to have to deal with that down here as much. So if you were to go ahead up here and look for this, is the file non-existent error, the easiest way would probably be to right here look for an error that's specific to the file not being there. And I'm assuming there's something in the OS package you can do to figure that out. And if that is the case, then you can go ahead and quickly, determine if that's the case and not return an error then, but for any other errors, return it. Okay, so we got load key values. So here we're going to do v.load key values. Error is going to be equal to this. If error is not equal to nil, return error. And then we're going to do key values. Actually, we're going to keep a lot of this the same now. So hex OK is going to be the key value. If it's not OK, we're going to return an error. Others are going to return, and it's not going to be hex now, it's going to be value. And we're going to return value, nil. So we're not doing this encrypt stuff anymore. You could keep doing it that way, you just end up having double encryption then, which is fine. I just don't think it's necessary for what we're doing. Okay, so now we're going to go down to set. We want to do the same we want the same idea. So we'll start by encrypting the value. And then we'll come down here. We're going to check for errors. We don't want to set the value yet. So here we want to do v.load key values. And if error is not equal to nil, we're going to return the error. Otherwise, we're going to, once this key values thing has been updated with whatever's on disk, we're going to add our key to it. And then we are going to want to, at this point, error equals v dot save key values, which we don't have yet. So save key values is going to, save this key value file. And I am going to mention right now that this is not thread safe at the time being. At least I'm going to assume it potentially has some issues here. Specifically, if we have multiple threads all calling set, they're both going to be reading and writing files at various times. We could have all sorts of weird issues there. But generally speaking, if we have, multiple different programs or processes all trying to do this is also going to cause issues. We could add a mutex to this specific vault that says, you can only access this file path that only one person can access at any given time. But that still is going to leave. Well, let's just go ahead and do that. It's not going to solve all of our problems, but it'll probably help a little bit. So what I mean by that is it'll help a little bit in the sense that it'll allow us to make set. We can make sure that we do something like v.mutex.lock defer v.mutex.unlock. So we can just do set and get. I'm not even sure if get's going to matter, but it's fine. And by having this mutex, what it's going to mean is an instance of get and an instance of set, or two instances of set, won't run at the same time because this mutex will be locked. So that's going to avoid any issues where, two different Go routines call set at the same time and they end up trying to overwrite each other on accident. So, if you have two Go routines that both get to this point, they both load the same stuff, and then one sets the value of A or some key A, and then it saves it, and then another one sets a value of B, then it saves it. Well, this one never loaded the value of A that we saved, so it's going to overwrite that without the A being present. So that's what this mutex is doing. It's going to cover that use case, but it's not actually going to help us with, having multiple, if we open up multiple vaults with the same file path, it's not going to help us with that. Or if we have multiple Go routines that are all, not Go routine, like if we have multiple programs, so we have two different servers that are both using the same file, it's not going to fix that either. And I'm not even going to try to handle that right now. I'm just going to let it be. Okay, so we need to write save key values. So what I want to do here is I want to, so there's, I think I'm going to use a bytes. So I want new buffer, I think. So I'm going to create this buffer. And what I'm doing with this buffer is, actually I'm going to use a string builder. RSB strings.new builder, or .builder. Okay, so string builder is something that's new in Go 1.10, I think. Or it's one of those versions, I don't know. So what I'm using about this, or what I like about this, is it has a write method. So it implements the io.writer interface. But it's also really nice to take whatever was written to it and turn it into a string. So what we're going to do is we're going to take whatever's in key values and we're going to encode it and write it to the string builder. So we're going to do something like encoder is going to be json.new encoder, and the writer is going to be the string builder we have. Then we're going to say encoder.encode v.key values. We're going to check for an error here. Then we're going to say if the error is not equal to nil, we're going to return the error. And then we're going to continue on down here. We're going to say, assuming that this wrote correctly to the string builder, we're going to then encrypt everything that's in that string builder. So we're going to call encrypt.encrypt. And you'll notice here that very shortly we're going to come back up here and fix load key files because we're not decrypting there. I forgot about that. So v.encoding key. Plain text is going to be sb.string. And this is going to return a string or an error. Encrypted JSON, error. If error is not equal to nil, return the error. And then we're going to do f comma error equals os.open. And at this point, we're using open file. And I'm going to go back here to the docs. We want open file. And I'm just going to grab, I like coming to the example here because this is a good default set of permissions. This will give us permissions to the name of the file is going to be v.filepath. And then these last two arguments are going to be the ones I copied. So it's read, write, and create. So we have all that. We really only need write and create, but I'm just going to leave it be. If error is not equal to nil, return the error. Otherwise, we're going to write to this file with our string. So we can just do fprint to the file. We're going to write encrypted JSON. And this might be hiding in, nope, it's not, okay. And then the one thing I forgot to do is I didn't defer f.close. And then I think up in read, I never did that either. And this does need a colon equals. Return nil at the very end of this. Okay, so this should write an encoded value. I think I need a pointer to this. Yeah, I do. So this should get a string builder, encode whatever's in the key values to that string builder, and then we can call string builder.string to get the string value of it. We're going to encrypt it using our key, and it's going to give us some JSON that's encrypted. And then we're going to write that. We're going to open up the file. We're going to defer closing it. We're going to write to the file using fump.fprint. And then, fprint's going to allow us to pass in a writer to write to. And then we're going to return. So up here in load, we need to make sure that we decrypt it before we actually do this JSON stuff. So what we need to do is right around here, we need to actually do, well, I guess this will be an easy way to do it. We'll do var sb strings.builder, and we'll do io.copy. Destination is going to be the string builder. The source is going to be the file. I think this can return an error, so I need to... it's written in an error, yes. There's like a million different ways to like write to, copy stuff from one to another or write things, and especially if you want to read a file and get a string version of it, there's like an ioutil.readall. There's a bunch of different ways to do it. So you're seeing me do things like io.copy or the strings builder. Really, whichever way you want to do it's fine. I'm just sort of doing whatever strikes my fancy. So I've got the string builder. I have went ahead and copied everything into it. I'm going to say if the error is not equal to nil, return error. And then we need to decrypt this. So I'm going to do decrypted JSON, comma, error is going to be encrypt.decrypt v.encoding key, and this cipher hex is going to be sb.string, whatever we stored the file. Again, if error is not equal to nil, return the error. And now we need to turn this into something that can be a reader. So we're going to say strings.newReader, and we'll pass in decrypted JSON. And then we're going to pass R into our JSON decoder, and then we're going to decode it, and that should be good. So, we have to do a little bit of work creating a string builder, copying stuff from our reader into it, and then eventually taking whatever value we get and putting it back into another reader. So that's a lot of what's going on here. And then down here, we're doing something, I think we're doing, well, it's not quite the same. Yeah, it is actually. We're getting an encoder, or we're creating a JSON encoder. We have to get some sort of writer to write to. And then we have to convert it back to a string. And then once we have a string, we have to then write it to a file, which means we have to write to this writer somehow. Okay, I want to see if this works, so let's save it. And let's go run command/demo. Alright, there's no secret.memory anymore, and that's fine. Let's go to demo. Let's make this secret.file. We'll call this secrets.secrets. Alright, well that doesn't appear to be right. So if we look at this, this is at least something hashed. So what I'm going to do is I'm going to come through my code, and I'm going to start figuring out, what went wrong. And I think the easiest way to do this is to just print out things as it's supposed to be coming into plain text. So right here we should have decrypted JSON. So I'm going to go ahead and print that out. And just run this. So it looks like these keys are still getting hashed somewhere. At least that's what it looks like is happening. Here, if you look at demo key and this, this part here, this value that's being stored in there definitely looks like it's something that's already hashed, which strikes me as an issue because it means that, well, I think what it means is that when we call set, this some crazy value is getting encrypted, and then the entire thing's getting encrypted and stuck into the secrets, or stuck into the secrets file. So now I need to figure out why this is happening, and you can see this right here is why. All right, we see encrypted value is going to be this. So I need to get rid of all of that. So we're going to load the keys, key values. As long as the error is not nil, we'll return it. Then we're going to say this is just going to be value. And we'll save, then we'll be done. All right. So our get and set's a little bit simpler now, in the sense that it's not actually simpler because we have to do the mutex and the load key values. But what I mean by that is that we're not worrying about the logic of encrypting these key values. All we're doing is just getting and setting them. All this code here that involves loading them is what's actually handling the encryption stuff for us. So now let's try this. All right. I'm not sure what this is or why I'm getting it printed out. So we got some crazy value printed out, but I need to figure out where or why this is. It's the only print line I know of. I'm not sure why there was extra stuff in it that one time. Oh, it's... no? I'm not actually sure what was going on with that, but everything appears to be working correctly. You know, we're getting some crazy value every single time. We could do... add this print line again to see what happens. What I'm trying to figure out is why we're seeing this weird stuff. Unless... I'm honestly not quite sure. I'm not entirely sure what's going on with that. Because I'm not sure what would be introducing this. Well, I don't want to spend too much time on that, so I'm just going to go ahead and let it be for the time being. Which I don't love doing. Let's go ahead and add a couple more demo things just to see what happens. So 1, 2, 3, and we'll do 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we'll get these three values. And I'm just going to ignore these errors. Well, never mind, I'll copy them. Then I'll make these two, not creating a new variable. All right, demo key 1, 2, and 3. And then we need to get rid of these colon equals. All right, everything seems to be working right here. I'm not sure why that, that decrypted JSON string was having weird values in it, but I'm not going to dig too much into it for the time being. I think we're good with all this. I do want to try one more thing. I want to see what happens if I just get rid of all these sets. If we just do gets, that seems to work fine too. Because we have that secrets file it's reading from. And you can see here that it's just a pretty gibberish file. We don't really know what it's doing. So I think that's enough for this part. I'm going to go ahead and uncomment this. So it's back in. I think this is enough for what we wanted to get done in this specific video. In the next video, we're going to actually look at how we can take a lot of this vault.go code, and we're going to try to not have to do all this go from a reader to a string back to a reader and that type of stuff. We're going to see how we can, essentially use our encryption code to create a writer or a reader that we can just sort of chain to make this code much, much simpler. So in the last video, we created all of this code here in the vault.go file. And what I'd like to sort of point out is that if we look at all these load keys and, all of these save keys stuff, realistically, what we'd actually like for this to do is something like, actually, let me just show you what I mean. It'd be really nice if save keys was really something like func v vault write keys, write key values. And it took in an io.writer and returned an error. And the reason I say that would be nice is then all this would have to do is something along the lines of encoder is going to be json.new encoder with the writer. Error is going to be encoder.encode v.key values. If error is not equal to nil, return nil. Or sorry, it should return error. But I mean, actually, we can just say return this. And that's what our write key values function ends up looking like. And then if we wanted to do, say, func v vault, read key values, all it would need is an io.reader. And it could do something like decoder is going to be json.new decoder. And it's going to say it's going to take R. Then we're going to say error is going to be decoder.decode and v.key values. And then we're going to return. So we can just return this. And notice how these two functions are much, much simpler. So our life would be much easier if we didn't really have to think about files and converting things from a string, encoding everything into a JSON, then getting a string and encrypting it and doing all that stuff. So what we're going to look at is how to create some IO writers and IO readers that make this a little bit more plausible. So to do this, we're going to jump back to the Cipher package. And first, I just want to mention the stream interface. So a stream represents a stream cipher, and it's basically anything that just has the single method XOR key stream with a destination source. So that's worth noting because it means that if we go to our encrypt code and we come down here and have this stream is actually what that's our stream. So we could say func encrypt stream key string could return a cipher.stream. And, we could just take that and use that. But what's even more interesting is, and you might have seen the autocomplete there, there's also a stream reader and a stream writer. And the way these basically work, if you scroll down through this enough, is that you can actually write your code in a way that you can pass it, say, a file or something like that, and it'll actually decrypt the file as it reads it. So let me just show you what I really mean by this. We're going to do a stream reader or an error. I think those are the two possible options here. All right, so encrypt reader, we're going to pass in a key, just string, and we're going to pass in R, which is io.reader, and we're going to return a cipher.stream reader or an error. So I'm actually going to take this chunk of code here, and I'm going to turn it into a func encrypt stream. This is going to return a cipher.stream or an error. And this is just going to return the stream here at the end. And then in these cases, it'll return nil and an error, nil and an error. And the only part that we don't have here is the initialization vector, which do we need this right now? I'm trying to figure out. I think this whole set of code isn't relevant to what we're doing. No, we need the initialization vector. So if we pass in an IV, then I can get rid of all this and just assume that it's set. So then in this code, I can do something like this. So I just kept this code. I put it back in here. And then I'm going to do, I think I want stream. My error is going to be encrypt stream, pass in the key, initialization vector. And then we're going to say if error is not equal to nil, return empty string error. All right, so this code pretty much works exactly the same. It just uses this new function up here to get the encrypt stream. And that's just essentially just allowing us to reuse some of this code. It's not a ton, but it's a little bit of code that we get to reuse. So then down here, I'm going to take all of this and basically we need to take the reader and no, we're going to do the same thing here. That's right. Okay. Oh, and this is an encrypt writer is what we actually want. I just realized that I was doing that wrong. Because right now we're writing. So when we're encrypting, we're writing. That means like we're encrypting data to then write it to a file. That's why I want the writer. So I want encrypt writer. And I'm going to paste this ciphertext code in here. And I'm going to show you that this is not technically right. We're going to go ahead and say ciphertext. Actually, we're going to say IV is going to be make. It's going to be a byte slice. That is AES.blockSize. Then we're going to read from the rand into IV, returning nil, error if there are any. And stream writer. I don't know if this needs to be a pointer or not, but we'll keep it a pointer. Trying to look. Yeah, they use pointer. It seems like they're using pointers, so I'm going to stick with using a pointer here. Okay, so the very first thing we're going to do is we're going to create this initialization vector, and we're just going to make a slice. We're going to read into it, and then we're going to return the cipher stream. We're going to come back to the initialization vector here in a second. So we're going to say stream, error is going to be new encrypt, or I think it's encrypt stream with key and IV. If the error is not equal to nil, return nil, error. And then we're going to return cipher dot stream writer. And stream writer, I'm going to look it up here, has a stream, this right here, wio.writer, and an error which is unused. So what we're going to do here is we're going to say that S, the stream, is going to be the stream we just created, and W, the writer, is going to be, I want this to be W, not R. W. And since these are really short variable names, I'm just going to make it all in one line. So what this is ultimately going to do is it's going to take our stream and it's going to wrap it with the stream writer around this writer. So anything that we now write to the stream writer will use our stream to encrypt it, and then we'll go ahead and write it to whatever writer we passed in. So what this means is if I called encrypt writer, so if I opened a file, said file is going to be os.create with some stuff, and then I did encrypt writer with some key and the file, and then I get some other writer here, I can take this new writer and I can just pass it wherever I was normally going to pass my file, and it'll make sure that everything that should be written to that file gets encrypted before it's written to that file. So that's what's going to be really cool about this, and we're going to see that when we get to that code, you know, how that works. But there is one thing that I need to do here. Before we were adding our initialization vector to the start of our string that we had, and we're not doing that now. So I definitely want to make sure we're doing that. So the easiest way, in my opinion, is to just write to the W with the initialization vector right here. So we'll do w.write, and we'll pass in IV. We'll do n, error. If n is not equal to length of IV, we need to return nil, some error. I don't think this should happen, but encrypt, unable to write full IV to writer. So we'll cover both of these. If n is not equal to the length of the initialization vector, so if it didn't write at least that many bytes, because I think it's write will return the number of bytes that were written, or if the error is not equal to nil, it'll return this error. Okay, so we've got our encrypt writer, and we'll say encrypt writer will wrap the provided writer with a new, let's say encrypt writer will return a writer that will write to the write encrypted data to the original writer. I think that's probably close. Yeah, it's complaining because this is like stuttering, but that's because I have both encrypt and decrypt in the same package. I probably should have named this package Cipher. But, I mean, I guess I could change it. I can rename this to Cipher. Now it's just going to be Cipher.encryptWriter and Cipher.encryptReader. So, not really sure how much that helped, but we did it. Okay, so now we're going to come down here and do the same thing for decrypt. And, it's going to be the same idea here. Encrypt stream, I think this is just going to end up being stream. Because I don't think this ends up changing. I think we're using the same thing down here. Alright, so where do we do our stream? Oh, this is decryptor, never mind. Definitely don't want to do that. So I'm going to come down here, the decrypt, and I'm going to grab my code used to get this stream. It's probably not all of this, but we're going to try to move it all. Func decrypt stream. It's going to take in a key, which is a string, I think. And it's also going to need an IV, which is a byte slice. And it's going to return a cipher.stream. Or an error. Alright, so we do this part. We're going to return nil, error. Then we have the ciphertext. We're going to decode it. And this is where it's getting the beginning of this. So this code is all very specific. So I'm going to actually take all of this, pull it up here, or pull it back into here. And I have all of this code, so I'm going to paste that there. So we get the initialization vector, and this is actually going to become sorry, I'm looking at this code. So we get the initialization vector, we got this. Do we need... So stream is going to be new or decrypt stream. We're going to pass in key and IV. I think that's right. And I don't remember where the block came from. Oh, it comes from up here. Oh, I'm not returning this, that's why it's complaining. It makes way more sense. Okay, so again, this one isn't like huge. It's kind of similar to encrypt stream. It's pretty simple. But it just allows us to sort of save a little bit of that effort. So we're going to say stream, error is going to be decrypt stream, key and IV. And then I don't need this line. And we're going to say if error is not equal to nil, return empty string error. And the rest of this stays the same. Okay, so now we need to add a decrypt reader. And this is where things are going to be a little bit different. And this is going to take in a key, just string, an R and IO.reader. And then it's going to return a cipher.streamReader or an error. And this is going to be a pointer. Okay, so the reason I say this is going to be different is up here we're reading block size from the beginning of the string that we have. We're going to go ahead and take the string that we have. We're going to decrypt it into this byte slice, or decode it into this byte slice, and then we're going to get the first chunk that's block size. Well, down here we're going to actually need to read from the reader. So we're going to need r.read, and we're going to need to read exactly block size. So we're going to say IV is going to be make byte slice. That is AES.blockSize. Then we're going to read in here. And we're going to say n, error is going to be this. And just like up here, we need to make sure that we return errors if there are any. So we're going to say if n is less than length of IV, or if the error is not equal to nil. So we're going to say errors encrypt, unable to read the full IV. Okay, so this is already a pointer, so we don't need to worry about that. All right, so this gives us the initialization vector. Now we need to create the stream, which means we need the key, which we have. So I'm gonna go ahead and grab this stuff here. Trying to make sure there's nothing else. Nope, all this is decoding stuff. So here we're gonna say stream, comma, error is gonna be decrypt stream with the key in the initialization vector. If the error is not equal to nil, return nil, comma, error. Otherwise, return and cipher.streamReader. And if we go back here, stream reader is defined as having a stream and an IO.reader. So we're going to say S is going to be the stream, the reader is going to be R. And I'm not sure why it added nil at the start. I have like a thing set up whenever I save to try to fix my returns if I don't have all of them, but it mixed up the order there. Okay, so decrypt reader is going to be the opposite of encrypt writer. So I'm going to copy the comments up here and bring them down. We'll say decrypt reader will return a reader that will original or from the provided reader and return and provide. Okay, decrypt reader will return a reader that will decrypt data from the provided reader and give the user a way to read that data as if it was not encrypted. I feel like that's a horrible description, but at this point I just kind of want to get this done. I feel like I've been working on this part for a long time. And we haven't even done like CLI stuff, so that's definitely something I want to get to. Okay, so we have the decrypt and decrypt reader. With all of that, I want to use it. So we want to go to Vault, and we're going to go here, and we're going to go to save key values, and so we've got read and write key values. Really what we want is just a way to save and refresh our Vault. So I'm just going to go ahead and just change this to be save, and then this I'm going to call load. And I'm going to go ahead and move load. Actually, I'm going to move save up top. Actually, I'm just going to move it right here. I think that's fine. I'm doing this because I want save right before the write, which it uses, and I want load right before the read, which it uses. Okay, so in here, load, what it's going to do is it's going to open up the file exactly like it was. It's going to check for errors, and if there are any errors, it's going to just set the key values to a new map and return nil. And then it's going to defer closing the file. And then from here, what we want to do is we want to create a new reader that is a decrypted, it's a decrypt reader. So we're going to say R is going to be cipher dot decrypt reader. And this is going to be a little bit weird because it was trying to do, I need to delete that. All right, so we got decrypt reader, and we're going to pass in, what are the arguments? Key and the reader. Okay, so v.encoding key, and the second part is going to be the file. So this is r, error, and if error is not equal to nil, return error. All right, so now we're going to say decoder is going to, or now we're going to say v.read key values. The reader is going to be this new decrypt reader that we just created. And this can get an error, so we'll say error equals that. If error is not equal to nil, return error. And we can get rid of all of this stuff here that was doing this whole like copy to a string, do weird things like that. So this is a little bit shorter. I mean, we still have to open the file and handle some of that stuff, but you can see that this part is definitely much simpler than what it was before. Now we're going to come down here to save, and we're going to be doing something very, very similar. We're going to say we're going to open the file first. So I'm going to go ahead and copy all this code and move it to the top. So we're going to open that file, and we're going to defer closing it. And then what we're going to do is we're going to say new writer, comma error is going to be cipher.encryptWriter. It's going to take v.encoding key, and our file is the writer. And then we're going to say if error is not equal to nil, return the error. Otherwise, we're going to go ahead and encode all of our data into W. So JSON.newEncoder with W. It's going to encode the values. And I think it's just going to check for errors there. So we can just do return. Oh, we don't even need the encoder isn't something we actually have to do. We can do return v dot write key values is what we called it, with W as our writer. And I say that because I think up here I might have, yeah, I don't know why I just didn't return this. So read key values and write key values are really so simple that if we wanted, we could just stick them in here. But what I like about this approach is that down the road, if we wanted to change the way that we are encrypting or anything like that, this part doesn't change at all. I mean, really the only thing it's changing is how save, wraps it with an encoder. And we could also do some other stuff to wrap around that. I will mention at this point that I don't think any existing secret files are going to work with this code because we're no longer encoding it into hex like we were before. We're just writing directly to the file. But I am going to go ahead and just try to run this. I'm going to guess it's going to, load key value 67. So I think this is going to be load and save are the two that we want. All right, so it looks like we're storing and loading these values. And now I'm going to open up secrets. It says that it's not going to show much. So you see here, this is just raw binary data. It's just writing bytes to the file. And that's why, it's going to be a little different than it was before. And it's probably actually going to be much smaller file sizes. But the whole thing is still working because, we're now writing and reading files. And if I go back to our demo, I can actually get rid of all these writes now that I have a new file. And I can just do reads, and these all still work perfectly fine. Okay, so that's all that we're doing here with this Cypher stuff. I just thought it was really cool to see how you can do this interface chaining. And the end result that we end up getting is that in vault.go, whenever we, it's especially cool if you look in here in the encoder, because, so whenever we have the encoder, so this JSON coder is going to encode this to JSON, and it's going to write it to W, which in this case is our encrypt writer. So it's going to write it to encrypt. So it's going to write it to like something like this, this thing that we created here. Well, that thing is then going to take the data, it's going to encrypt it, and then it's going to write it to this writer here. Whatever we passed in is this writer. Well, if we come back to our code, the writer that we passed in here for the encrypt writer is going to be this file that we opened up so that we could write to it. So you end up with this cool chain where when JSON writes to its writer, it then writes to the encoding writer or the encrypt writer, which then writes to the file, which is a writer. So like you get this nice chain. And what's really, really useful about this type of thing is that you can have larger chains than that. So like say at some point, reading and writing from our files is really slow and we needed to, because we're only reading small bits at a time, then we keep going back to the file and then going back to our code. You could also write something that was like a buffered reader. So maybe it would read big chunks of the file all at once, like maybe a couple megabytes worth of the file all at once, and then it'll keep it in memory so that in the future, when this writer is a bad example, let me go to the reader down here or up here. So this is going to read from, let me go ahead and just get the order right. The decoder is going to read from the Decrypt Reader, which is then going to read from the file. So the file will have the raw data, the Decrypt Reader will take that raw data and decrypt it, and then it'll return the bytes to this, which will be reading those and turning it into this JSON object or decoding into the JSON object. And this is where you could put something like a buffered reader. So we could end up adding a buffered reader here. where it could, instead of like reading just as much of the file as we asked to read, it could say, okay, I'm going to read at least a couple megabytes of this file so you don't have to keep accessing the disk. So it's going to read all the file, or maybe a couple megabytes, store it in memory, and now every time Decrypt Reader calls read on it, this doesn't necessarily have to read from the file, but we got that functionality without having to specifically write it for our pipeline. We could just slap another reader in there. So doing this interface chaining is a really cool way to write reusable code that you can sort of plug into other programs. And that's why if you ever check out the IO package, there's a ton of things in here that do really cool interface chaining type stuff. So if we look at, where is it? There's like a T reader, I think. Okay, yeah. So T reader is something that you can take whatever you're reading, and you could pass in another writer, and everything that it reads, it's going to also write to W. So you end up with this cool little wrapper around a reader where, like, say you're reading a file, you could actually have this write the entire file contents to your logs while you're reading it in the rest of your code without the rest of your code having to change, because it just expects a reader of some sort. So there's a couple examples here of different things like this. They're gonna seem maybe confusing at first whenever you're first getting into language, but this is like where you'll really see the power of interfaces in Go, is when you can write these really cool ways to chain things, especially with the reader and writer. These are the ones where it happens really, really often. You'll also see it happening really often with web servers. If you ever look at middleware, really all middleware is interface chaining. It's a way of sort of making that happen so that you can have multiple different handlers sort of do things like verify the user's logged in, and then go to whatever handler was supposed to happen. You pass the code along to that handler. So that's what I really like about, or what I really wanted to show you with this exercise was this interface chaining stuff, and I hope that it was, somewhat easy to follow. So there's going to be one more video, I think one more, where we're going to take all of this code and basically just turn it into a CLI as well. But aside from that, I think that's everything for this exercise, so I hope it was enjoyable. Okay, so I'm going to try to keep this video a little bit faster, because most of the stuff we're going to be doing is going to be like stuff we've already covered in other exercises, so I don't want to spend too much time there. The first thing we're going to want to do is just make a CLI. So to do that, we're going to use Cobra again, which we did in the task exercise. So if you need a refresher on it, you can check that out. What we're going to do is basically just take this demo.go. I'm going to rename it to CLI.go. And then inside of here, I want to, I forget what it's supposed to do. I think this is what I wanted. Yeah, so I got the Cobra docs up here. It's going to be something like we get command and we execute. So I don't have a command package yet, so I'm just going to go ahead and just let this be. So then inside of here, let's go ahead and add a new folder. It's called Cobra. And we're just going to put all our Cobra commands inside of here. So I'm going to create a new file in that. It's going to be root.go. So we'll go package Cobra. And we're going to say import github.com/spf13/Cobra. Because I'm going to need that. Our root command is going to be equal to and cobra.command. And I could have just let my auto imports bring Cobra in. I'm not sure why I didn't. And then inside of this, what do we need? We need use, I think, which is secret. We'll just say it's going to be like the name of the app, the binary, I think. And then the next is short, which is secret is an API key and other secrets manager. I don't know. I think that's fine. And then we're going to do, I think that's it. All right, so let's go ahead and create a new file in here. We'll call it set.go. We'll do package Cobra. And then we're going to do something similar. So let me go ahead and grab this. We're going to do set command is going to be a Cobra command. The use is going to be the word set. So like this is the sub command. And the short description sets a secret in your predefined, I don't know how to put this. So that's a secret in your predefined, or in your secret storage, I don't know. I don't want to spend too much time trying to get these. And then run, which is going to be the function that actually does something. So it's going to be cobra.command, args, which are going to be strings. And then we need an init. And if I'm getting most of this from the Cobra docs here. So if you look here, you'll get a lot of this. I didn't just make it all up as I went. I checked this all quickly before the video. So then we want a func init. It's going to be something like root command dot add command set command. It's set cmd. Okay, so I've got set, and I'm just going to let the implementation blank. And then we're going to say get.go. Just going to, do get command. This is going to become get. Get's a secret in your secret storage. All right, so there's get. So I did saved it as get, and then just altered a couple things in it real quick. So from here, we should be able to build the CLI and run it. If we come back to here, and I'm going to go back to Cobra here and look at, I think you just want the command.ex. I think it's going to be something like root command.execute, something like that. So cobra.root command.execute, something like this. And my disk is almost full. That's not good. So import github.com/gophercises/secret/command cobra. What do I call this? Is it root command or just root cmd? Okay, that's why. .execute. Close this. All right, we at least have these things showing up. So I'm going to pause real quick. My storage is almost full, and then I'm going to resume this. Okay, I think I cleared up enough space to finish this, so we're going to try to fly through this. We've got the command executing. I need to find a good way to get to get this file. So I'm going to assume the file is going to be in the home directory. So I'm just going to go ahead to root. I'm just going to go ahead and add something like func home dir. And return a string. And I think I have, let me code. I think in the task project that we did, let me look. Sorry, it opened up over here. Let me bring it up. Pretty sure in main.go or somewhere. Yeah, we have this home dir. So I'm going to go ahead and grab that. And then I'm going to go back to this. So I don't actually need that in there. This is going to be an import. And I'm going to say home is going to be home.join, and we're going to use .secret, or .secrets is our file. And we're going to return that. Call it secrets path. And I'm just putting this in root because it's going to be used for both commands, so I think root's just kind of a good middle ground for it. So what we're going to do is v is going to be secrets dot file, and we need some sort of key. We need a flag for this. So how does Cobra do flags? Let's go flag. Let's go look at the docs. Okay, it's I feel like there's better examples of these in here. So you can set up flags for specific commands, but really we're going to need this flag for all commands, so I think it's fine just to go ahead and slap it in here. We can actually just put it in CLI.go. We can do var API key, although it's going to be hard to have it in here. I mean, I guess we could put it in these runs. I feel like there's got to be better description for it here. root command up persistent flags. It looks like it's just the same thing there. Just trying to look to see if there's a quicker way to do flags here. All right, so assign locally. All right, let me go up here and see where the flags were. How does it get the flag? All right, config file. Where's config file coming from? Is it just a global variable? Because I don't see where it's declared anywhere. Maybe that's what they're doing. I mean, I guess that's global variable is not terrible when we're dealing with a CLI type thing, I don't think. So I'm just gonna go ahead and say var encoding key string, and then we're going to do func init. We want a flag. I don't know what the difference is between persistent flags. To the command it's assigned to, as well as every command under that command. All right, that's what we want. All right, so for a global flag, assign a flag as a persistent flag to the root. This is what we want. Something like this, except we're going to want a string. So we're going to do string var p. I think p just has a shorthand. That's fine. All right, so and encoding key. The name is going to be key. Shorthand will be K, I guess. There's not really a reason for shorthand, but that's fine. Value is going to be empty string. That's going to be the default value. Usage. We want the usage here to be the encoding and the key to use when encoding and decoding. Secrets. Let's go back here. Does it do anything to parse these? Or does it do it for us? Looks like it just handles that for us. Sweet. All right, so we've got the root command persistent flags. Do we need anything else? We're going to print it out. I'm just going to do that again in set just to make sure both are working. All right, so we're going to go run command /cli.go, and we'll do set. Key is that, so we'll say key equals 123 ABC. Why are we getting extra weird garbage printed out? It doesn't make any sense to me. Maybe it's probably supposed to be dash key. So dash k equals 123 ABC. Probably do a space too. Yeah, that seems to work. Okay. Sorry, I was just forgetting how Cobra works for some of this. So I can just do dash k space and the key here. And I'm also going to verify that get works. All right, that seems to be fine. The space is added from this print line whenever you comma separate these. So if I did printf and did %s, new line here, this would, I just did it for set, didn't I? Yeah, I did, okay. Let's do this here for get as well, just to double check. All right, we're good. Got the key there. What we want to do now is we want to open up the vault with our home dir, whatever that happens to be, and go from there. I think I deleted everything that was in our last demo, so I don't remember what all we're setting or what key we were using, but I think we just had like a random key there. So what I'm going to do is I'm going to say vault is going to be secrets.file, encoding key, and this is going to be secrets path. I think this can return an error too. I'm just going to panic for the time being. I think that's fine. And this is probably import github.com/gophercises/secrets. I think it's just called secret, isn't it? That's probably what it's complaining about. And this doesn't return an error. So we need to return or worry about that right now. All right, so we're going to do v.get, and we need a command or an argument here. So I'm just going to say args0 with these args provided. That should be correct. And I'm going to hope that's right. I'll go look at it here in a minute. All right, so get key ABC, and then this is going to be Twitter API key. Okay, so the flags get pulled out of the args, it looks like, which is a really, really nice thing about Cobra. So when we call arg0, it's just giving us this Twitter API key string. Now, if you had spaces in your keys for some reason, you'd have to put them in quotes, but I think that's logical. All right, so we're going to printf. We're going to say key is going to be, or say key is going to be arg0. I'm going to say value, comma error is going to be .get key. If error is not equal to nil, panic with the error. Otherwise, we're going to print %s equals %s with a new line at the end. Say key value. All right, so that should be everything for the get command. And then I'm going to go to the set command. I'm going to copy or replace all this with the get command. And we're going to say key is going to be args0. Value is going to be args1. And we'll probably eventually want to add better descriptions to this, but I'm going to probably skip that in this video. You can, work on that if you want on your own, but I'm just going to let it be. All right, so v.set key value. I think this only returns an error. All right, so let's go build command/cli.go. Output will be secrets. One of the flags first, I'm guessing. All right, so we got secrets here. I don't know why I named it secrets plural. Whatever, I'm just going to move secrets to secret just to make it match. All right, we're going to run secret. Get. This will be Twitter API key. All right, so it's going to give us an error because it tried to look for something at the beginning of. I'm going to guess it tried to open up a file that didn't exist. And I don't really know if I want to dig into that right now. I'm guessing that somewhere in this vault.go code, it's trying to open up a file that doesn't exist and we don't handle that correctly. But I thought we handled that here. Or maybe the file was there and just doesn't have that value. That doesn't make sense though. Get.go 18. Let me at least see where the error started. Well, that's not helping me. Well, I'm going to skip that for now. I'm going to set something. All right. I'm going to guess that we're getting an invalid home path. That's the only thing that makes sense to me right now. Our secrets path. Let me grab this and just All right, so I'm going to build it. I'm a little stumped as to what's going on. Unless, do I have a file there? Yes, I do. I don't even know what's in it. It's probably from, it's a freaking JSON file. No wonder. It's not what I was looking for. Let me remove that. I think that's from my live stream where I was doing something a little bit different than this. So that makes more sense now. We don't handle that error perfectly, but I think that's fine. All right, value set successfully. Let me go ahead and get rid of this print line. And now we can do secret get Twitter API key. So Twitter API key equals some value. Maybe I want to add some spaces in that get. I got to build it. This is the one I want. Except I freaking named it secrets again. All right, if I could type today. All right, no value for that key. I should probably change some of these errors. Some of them are kind of more meant for the back end. I should probably just print out nothing in a lot of these cases, so. Let's do a return. Well, I said I should probably just keep it for now. This is where you'd want to come through here and sort of figure out what makes the most sense for your CLI. Is whether or not to set things. I don't know why I can't type secret today. All right, so now it just prints out nothing. Or we could do something like print line, no value set. Except I probably want to return here. All right, there we go. We can just say no value set. That makes sense. Now set, on the other hand, I'm not sure, but that's okay. So if I do dash secret set demo abc123 secret set or get demo, there we go. We've got everything working. The only thing you might want to add, which I'm going to leave for like a bonus exercise for you to do, is you might want to add a command like dash secret list, which will list all the keys you have value set for. You might also want to have a secret RM or delete or something like that. So if you want to try to add those, you can. You'll have to go to the not secret file there, but this vault.go, and you'll have to come down through here and change this by adding a couple extra methods to it. And it's probably worth commenting some of the code to at that point. But I think this is a good stopping point. It was an interesting exercise, especially looking at some of the Cypher stuff. I think it's something you might not dig into very often, but it was just kind of cool to dig through it all and see how it worked. All right, hope you enjoyed this one.